What's that do? Yeah. Okay. Sorry, my dog's acting up. Hopefully she'll calm down in a second. Let's see. I'll get started in just a minute. Sorry, I'm trying to get used to the new roster they just sent out a little bit ago. Trying to, oh, come on. Well, okay. All right, that should be good. All right, so for tonight, what we're going to be going over is Unit 12, and we should, if we've got time, we'll go over 13. If we don't, we can cover it not tomorrow, but Wednesday. Sorry, not 13. I'm at 17. So it should be 12 and 17 tonight, and then there we go. So I'll go ahead and get started on 12, or Lord, I keep getting my numbers mixed up today. 15 and 17, not 12 and 17. Sorry about that, guys. So I'm going to kind of go really quick through 15. The reason why is because you're going to see the same stuff again and again and again. When you take your air conditioning class, when you take your furnace heating class, pretty much all your residential systems, you're going to learn this again. We'll go over it. I'll discuss it, but the next meeting we have at 8 o'clock, I'm going to be getting online with the Cengage mobile lab app, basically. Coach and I were already talking to Mr. Holloway. We're going to make sure everybody gets a copy of what I'm going to show you guys tonight, which is basically this thing right here, this little coated piece of packet paper, it gives you access to an online simulated lab that you can access on just about any web browser out there, and some of them have it where I think they do it for apps as well on the phone. So, yeah, I'll just go ahead. We'll go through 15 real quick, and then I'll show you guys that app, and we'll run through some programs. We'll do some troubleshooting, and I'll show you guys basically how to do some basic service calls, and I'm going to have you guys, help me out, and we're going to walk through everything together as a group. So, all right. So, getting started. All right. So, residential air conditioning systems, as far as controls are concerned, you are always going to have it where it's going to be 24 volts is going to be the pretty much standard across the board. Out of your 24 volt controls, you will always have the following thermostat connections. And this is just standard of what it's going to be. You're going to have red, or your R terminal. That's going to be your 24 volt power. You're going to have your yellow Y terminal, call for cooling. Your white, your W. That's going to be for your call for heating. You've got your green, G, and that's going to be your call for your blower motor or your indoor fan motor. And then the only other ones you're going to have are the orange, which would be for your reversing valve. You'll only see that on heat pumps. And then you'll have, depending on which one it is, it'll be black or blue. You'll have a C wire, which is your common, not common, common. So these thermostat connections, as far as what these different letters are always going to mean, it's pretty much universal when it comes to air conditioning residentially. Okay. So, yeah, it's not the clearest thing in the world. So you've got where it's cooling, heating, blower motor, reversing valve. The big thing with this is understanding that you can do a lot of troubleshooting with that. So how a typical switch is going to operate and how a typical control system is going to work is there's going to be one major control, one major switch that's going to turn everything on or off and make us go through the cycle of either heating or cooling or turning the fan on. And the one thing that's going to cause that and what's going to make the difference is going to be our thermostat switch. So a thermostat, keep in mind, it's just a temperature switch, right? There's two ways that temperature switch can be set up. So they're going to close on a rise or close on a fall. All right. So you would have it where the thermostat's got its R connection. It's going to have its R connection. Oh, come on. Trying to make it red. So you got your 24 volts sitting behind either one of these. All right. Now the thermostat's going to have it where you as a user will choose, are you in heating mode or cooling mode? All right. And that's going to basically make the decision as far as which path will the 24 volts actually be connected to, either cooling or heating. So on the other side of this, we're going to have it where we'll have a yellow wire. All right, and that's going to be our call for cooling. all right? And you've also got where you're gonna have a white wire, and that'll be our call for heating. So what's gonna happen is both of these temperature switches are gonna activate different ways. The call for cooling switch will close on a rise. I've got that little arrow right there. That switch will move upwards as the temperature increases, and then once the temperature gets to, you know, right about what we're set at, it will, or above what we're set at, it will close, it will make contact, and now this 24 volts is going to be able to go to the other side. Now, what we do with the 24 volts is important. That's the thing that makes the difference between the cooling call and the heating call, was where that 24 volts is headed. So for your cooling call, typical system, you're going to have it where it's going to be turning on your indoor blower relay and outdoor contactor. All right. So typically it's going to be your cooling call is going to send a 24 volt signal to two coils. One to the coil to the contactor outside. All right. So you've got that contactor coil, a little 24 volt coil. All right. Now temperature rises, 24 volts instantly. Two spots it's going to go. One, that contactor outside, it's going to send that voltage through that coil. When it does that, you're going to have an electromagnet. It's going to pull down, close that armature, make it so we have a complete path, allow for power to go out to our outdoor unit, and to turn on our compressor in our outdoor fan motor. We're going to have a similar situation with our blower relay for the indoor fan motor. It's going to be trying to make sure that we can have our fan motor come on right when that call for cooling comes on. So it'll go to two different places. That 24 volts will be sent to turn on the blower fan and to turn on the outdoor fan motor and the compressor at the outdoor unit. But it's going to be controlling two different low voltage coils to turn on that high voltage. That's the whole idea behind this, as opposed to having to have high voltage switches or you know, really complicated high voltage electronic control boards, or you know, really crazy controls and everything like that. The simpler idea is, okay, we'll have it where we send 24 volts through coils, through safety switches. That'll also be 24 volt switches, whether it's pressure or temperature, and these are all things that we're going to get into. So we've got a lot of different stuff as far as controls are concerned. There's a number of different things for residential air conditioning, but we'll get into a lot more specifics as we continue. So again, like I said, I'm going to try and do my best to get through this. It's a pretty dense chapter, but you're going to see a lot of this stuff again and again, and we're going to be testing on this and trying to get you all prepared for everything when it comes to residential air conditioning, because majority of people who start out in heating and air conditioning, residential is where they start out, because it's a big field, needs a lot of technicians. So not a bad place to go. That's how I started. I really enjoyed it. Plus you have to help people out individually as opposed to, you know, just working with some big business kind of thing. Anyways, all right. Residential systems, we've got two different kinds. We've got packaged units and we've got split units. All right. Packaged unit simply means that we're going to have it where the outdoor unit is going to be that outdoor unit will have it where everything is connected outside of the building. So we'll have it where we've got our structure. This is a terrible house. And it's just really bad builders. They have a drunk roofer. We'll see how that goes for them. But the cool thing about this is with the package unit, you just have to worry about making sure that you've got connections for ductwork. And all the ductwork's got to do is it's just got to connect to outside. That's where the entire outdoor unit is going to be. So you've got your entire unit outside. This includes your evaporator. This includes your evaporator, your condenser, your compressor. Everything is going to be in that one single unit outside. The split units are going to be a little bit different, where they put a small condenser outside, and then they've got a air handler inside, and they'll have them connected by a refrigerant line, thermostat wires. And these will be your more common ones, or split systems. Package units, typically the main reason why they're not used residentially is space. Most residences have it where you can access the ductwork inside of the house, you can get to it. And because of this access, you can actually have it where you can fit an air handler inside, you can have a technician work on that and everything, and it makes life a little bit easier, because all you have to worry about outside of the building is a small condenser unit. You don't have to deal with a very large package unit. This package unit usually takes up a lot more space outside of the structure. Now, that can be beneficial for certain applications. One of the big ones is older homes, especially here in Richmond. Older residences, it's very common to see a package unit used. My place I live currently has got a package unit on it. And it's going to be pretty common for that. The reason why is because everything is outside of the structure except for two things: thermostat and your ductwork. So if you have it where there's not enough space in the walls of a building to put the air handler, that indoor connection of a split system, where your evaporator coil, your blower motor, and everything would be, that your air comes across. If it doesn't have space for that because the walls are too small, or you can barely fit the ductwork in there and that's all you're going to get in there, this is when you're going to see a package unit used a lot of times, because all you got to run through the walls is ductwork. That's it. Typically, that's when I've seen it used most often. And you'll see them as two locations typically. It's either going to be on the ground level outside in the backyard, or it's going to be on the roof. That's your more common spot you're going to see it. But a package system's got it where, because everything's out in one location, it makes it a little bit easier for some diagnostics, but it also makes it a little bit more annoying for the fact that, you're just outside the whole time. So whether it's heating season or cooling season, you're going to be out there in all the elements of everything, trying to work on the system. So it makes it a little difficult when you've got a bad stormy day. You can't get to the electrical panel just because, pouring rain outside. So that's when it comes down to certain things, it makes it a little bit more difficult. And another reason why, again, package units not as popular residentially. Split systems are. Split systems are what you're going to see, I'd say 95% of the time residentially, is going to be a split system, where you've got the air handler with the evaporator and the blower motor on the inside, and then outside you've got your condenser along with your compressor. The only other thing that y'all will see eventually, and you'll learn more about them as you get into your heat pump classes, is a geothermal system. And that's where it's going to be using a water mixture, or a glycol mixture, basically, to cool off our system. But they're very similar to package units. But again, y'all learn about geothermal when it comes time. They're a little more confusing, but they're really cool. Oh crap. Okay, there we go. All right, so split residential systems, like I said, pretty much your more common style. You've got where there's the evaporator, or not evaporator. Good Lord, I'm tired. There's the condenser unit outside. That's what we're dealing with typically. And you've got your air handler inside. And those are going to be your two sections that are going to have a lot of controls going out to them. Typically for the condenser unit, if it's just an air conditioner, it's not a heat pump, you'll only have to run a 24-volt control wiring. you only have to run 2 wires out there. A yellow for your call for cooling, so it says, okay, go into cooling mode, and on the other side of that contactor, you need to run a line back to common on the 24 volt side so that it can complete that full circuit. It can have 24 volts come in, go through a 24 volt load, like that coil, and then return back to neutral common. And that's what we're typically going to see a lot of times for an outdoor unit. So there's some basic controls y'all see pretty consistently. One is going to be this guy right here in the corner. I'm going to circle because on this control board in the bottom right, I'm going crazy with my circles. It's got it where right at the edge of it, you've got a set of letters, and it's the letters you've already gone over. And it's because it's not going to tell you red and common and whatever. It's just going to say R, C, Y, G, W. That's all you're going to see. And you're just going to have to know that R needs to be 24 volt power, C needs to be your common, Y is your cooling call, G is your fan, W is your heating. You learn those connections, and you memorize those. You can learn to troubleshoot and figure out a system very quickly, very easily, save yourself time, and also make it so that the system can keep coming back on faster, but save yourself time, get yourself more money, save the customer time, save the customer money. You know, it's always good to do that kind of stuff. So, you've got it where the control board and everything like that. The typical thing with these is you're going to see a basic layout. You're going to have one section that'll be 24 volt controls as far as connections to your actual thermostat wiring. And that's what we're seeing with this one right here with these screw terminals. Your other connections you're going to see are typically high voltage connections. So you'll have, you can see there's these large plugs that will usually be for switches and controls. So your pressure switches, your temperature switches, basically any sort of safety to make sure the system doesn't come on or turn off, or does turn off if an unsafe situation arises, whether that's overheating, overpressurizing, whatever it might be. That stuff is all fed back to the board there. And that lets the board know, okay, yes, we can turn on the heating mode, now we can turn on the cooling mode. So as long as 24 volt connections are good, as long as our switches and controls are good, the only other connections we're going to typically see is going to be our 120 or 240 connections. And you're going to see it arranged like this a lot of times, where on this one, you can see right here, there's like 5 connections. Those are all for neutral. It's called your neutral bus, all right? And it just means that your neutral terminal or neutral bus terminal, because much like a bus and an actual, bus station, this is basically where everything comes together. This is where they all meet up and they get back to one spot. And so we have a location where it's going to be all these neutrals. And then on the top here, we've got another section where it's going to be all of our power connections, all of our 120 high voltage or 240 high voltage feeding to our different motors, feeding to our compressors, our blower motors, our inducer draft motors, all those different components. So the board is really interesting because what it's going to do is it's going to receive 24 volt signals, and it's going to receive calls for heating, calls for cooling. When our thermostat closes, the 24 volts are going to come here. They're going to hit this Y terminal. So basically R has 24 volts leave this board, goes all the way to the thermostat, and it sits there at the thermostat. And once the thermostat closes that switch for either heating or cooling, that's when the 24 volts comes back to the board and comes into one of these connections, or comes into multiple. Typically, it's going to be your G and your Y, or your G and your W, because your blower fan has to come on in all cycles. That's what's going to move the air around in the structure. And then it's going to go through that board, all that 24 volt signal, everything like that. It'll go out to, it'll come into here, it'll go through a couple of safety switches, and then eventually it'll go through a relay. And when that relay closes, which there are different kinds, there are the ones that are going to be the manual relays, but if you look at this board, you can see these black squares all over it. Those are relays. Those are built into the board. So this might not even have its own independent relay for the fan motor. It might just be built into the board, which is extremely common nowadays to have more and more components included into that board, and less and less independent parts and pieces. This is because it reduces the number of things that can break, but also because it's going to make it where we have less things to have to repair and to maintain. So these relays here on this board, that's what you're really going to be seeing used a lot more nowadays. But it's going to be that whole idea. The only other thing on this board that I would say you look out for, what basically to troubleshoot it, we'll look and make sure, okay, are we getting high voltage in? Are we getting low voltage in? Are we getting high voltage sent out? Are we getting low voltage sent out to our different switches and components? And so the typical connections with the board is really just to make sure, as far as troubleshooting, is it sending that signal? Is it sending that voltage? Otherwise, bad board. But it's just a matter of understanding how to read those. And different manufacturers and different wiring diagrams y'all see will kind of explain what's connected to what's supposed to, and then from that you can figure out, okay, when should I be reading 24 volts here, or 240 here, or 120, wherever. Typically, you're going to see it where this is your basic setup as far as control circuits. So remember, circuits are just going to be anything that's got a complete combination of the following three, all right? Power, path, and a load. That's a circuit. So if I've got power, I've got somewhere where it's going through wiring, and it's got something it's going to do when that power gets to that spot, that's a load. All right, power, path, load. Those three right there. That's what I want y'all to always remember when it comes to the bare minimums of a circuit. It's got to have power, path. All right. So with the compressor control circuits, the big thing is you've got to where this is going to be power coming in to the compressor through our high voltage wiring. It's going to take that path, it's going to take on the load of the compressor, and then it's going to return back to neutral. That's always the last part of that path. Power comes in, goes into our load, and then finishes its path back to neutral or common. For 24 volt circuits, we're just talking about our low voltage circuits. So what you're going to see typically for a low voltage circuit, you're going to have your, Lord, let's see how this goes. You'll have your most common symbol tell you what is controls and what is high voltage, what is high voltage loads. And that's this guy, which is terrible right in the middle here. That's supposed to be a transformer. All right. So the transformer, what it's going to do is it's going to take it where we take on one side, typically for most residential systems, 120. We're going to take high voltage. All right. And we're going to hook it into the transformer. And then coming out on the other side, we're going to have 24 volt low voltage. All right. This is what's going to be controlling our thermostat and everything like that. You have your 24 volt leg, and then you're going to have another one which is going to be your common. Oh, Lord. Yeah, I don't trust myself writing with a pencil. So the 24 volts comes in. That'd be your R coming into your thermostat. All right, and then it's literally a manual switch that will set you into, let's say, cooling. All right. And then after that cooling switch, that's when you're going to have your actual temperature switch. So it closes on a rise in temperature. And then this connection goes to my Y. And now there's one last thing I've got to have that I'm missing from this. I'm missing a load, right? So that's when I've got to go in and I've got to have something for that electricity to do while it's going through that Y wire. This is where you're going to see the system will actually use, instead of just the Y doing nothing, it's going to go through a contactor coil, and that's what's going to control our contactor. That's what's going to go through that contactor coil, turn an electromagnet, close that contact down. Again, there's different ways that this is going to be wired up. It just depends on the manufacturer a lot of times, but typically what you're going to see is that cooling call, they'll have low voltage, send a signal, and then go out through that. Now, along with that, you can have extra switches. You can put switches in series with each other on that low voltage switch, so I can have it where coming from my cooling call through that temperature switch, well, it can go straight to the contactor, or I could make it where it has to go through 2 pressure switches and a temperature switch and another temperature switch, all to make sure that, okay, you know, I'm going to check and make sure I don't have too low of pressure to start up or too high of pressure to start up. I could put a time delay relay in there and make that part of the delay. So there's all sorts of different tools that we've seen that you guys have gone over or read about in your book that explain, you know, we've got so many different ways to control a system. All right, gotta get finished through this real quick. So package air conditioning control systems, what you're going to see a lot of times is it's going to be divided, again, between your control side and your load side. That's going to be your 2 different things you're going to be looking at. For package units, it's going to be nice because everything's right there. All the components are easy to access. Pretty much everything is factory wired. Very little of it is what's called field wiring, where you actually wire it in the field. That's things like your thermostat connections, your 120 or 240 volt connections. Those can all be run off of field wiring. So again, package units are going to have safety components, all sorts of different stuff. It's going to be the same kind of thing you're going to see on a split system nowadays for what kind of safeties will be involved and what kind of components. The only thing that's really different between either of the 2 is making sure that you know, you've got proper airflow in both is key and important. It's one of the most common problems that can happen with the system is improper airflow. Either, you know, the condenser coil outside has got a blockage because it's built up too much dirt and debris, it's pulled in too much crap across it over time, or a filter's dirty, or the ductwork is all clogged up with dirt and dust and debris. And you've got to have that proper airflow. It's one of the things for any kind of heating and air conditioning system. If you've got some problem and you're trying to figure out, I don't know what it is. I've checked all my voltages. I've checked all my components. I really think it's working fine. I think it's coming on, but it's just not cooling or heating as much as it should. Start looking at airflow. Airflow is one of the most common things that'll stop a system from cooling or stop a system from heating. I've had it where I went to a house, they had a brand spanking new air conditioner. Within 2 days, it failed. And the reason why, they hadn't changed their filters out. That was it. They just hadn't changed their filters out. And as soon as I removed the filters from the ductwork, the system started working perfectly fine within a matter of minutes. And I was just shocked at how quickly it made a difference, just increasing the airflow. So we're going to make sure that our coils are clean. We're going to make sure that our furnaces are clean, that our heat exchanger doesn't have a lot of debris built up on it, that our blower motor doesn't have a lot of dust on it, because that blower motor is going to be in contact with all the air that comes past that filter. Where that filter doesn't catch, the blower motor is going to catch it. It's going to pull in some dust. It's going to pull in some hair. It's going to pull in some debris. The problem with it is if you have a blower motor operating in those conditions, well, blower motor is going to have electrical wiring in it. It's going to have windings, right? It's going to have all those wires going through it and everything. That's going to make it so we've got a it can build up dust on it very easily because it's a magnet. So it's just what happens over time. All right, for heat pumps, one thing that's going to be very unique to them is what I talked about a little bit earlier. Is the orange or reversing valve. All right. So a heat pump is a pretty simple system as far as the concept behind them. And they are extremely common in Richmond, extremely common in Virginia because they're energy efficient. And we live in an area where the climate allows for heat pumps to work. Heat pumps typically work less and less efficiently the more of the winter that is below 40 degrees. Typically, we don't have super, super cold temperatures like that in Virginia, so we can get away with a heat pump operating pretty well. So how it works is you have to understand the basic refrigeration cycle with an air conditioner, or you're going to have it where you've got compressor, condenser, expansion device, evaporator. Right? The whole idea is we've got a very cold evaporator inside. Warm air from inside goes across that cold evaporator. Heat transfers from hot to cold. The hot air gives its heat off into the cold evaporator. It's going to absorb that heat. It's going to send that heat outside. Our condenser unit is going to be very hot. It's going to give off heat to the outside. So we have it where our indoor air handler is absorbing heat, and our outdoor condenser unit is giving heat off to the outside air. All right, so we absorb heat from inside of the building, and we're throwing it outside of the building where we don't care about it. With the heat pump, it's the same idea running in reverse. It runs backwards. That's the whole difference behind it. That's what a reversing valve does. It allows for the system, instead of a outdoor unit throwing heat out, now the indoor unit throws heat out. And the outdoor unit is going to absorb heat. The problem with it is that heat absorption over time, it's going to make that outdoor unit colder and colder and colder. And if you've ever seen it, you've probably seen an outdoor unit that's just covered completely in ice. It looks like a giant white ice block, basically. And what's happened is the entire system has been absorbing so much heat from outside, there's not enough heat left anymore. So water from outside is condensing on it like a glass of iced tea in the summertime. And then that water is going to freeze because it's so cold outside. So the system goes into a defrost cycle. You'll have extra controls for this. You'll have extra switches for this. You'll learn all about the defrost control cycle, how to troubleshoot, and work on defrost control boards in depth when you take your heat pump class, which is 155. Oh no, 150. Sorry, HVR150, which would be, I think, in not next mod. I think it's going to be 3 mods from now because we're currently teaching it. It's every 3rd mod we teach it. So in that class we go really in depth on how the defrost control board works and everything. But suffice it to say, you have it where it's basically just trying to make sure that we've got it's able to produce heat and everything like that. All right, I didn't get through nearly as many of these slides as I wanted to. But when we come back, we're just going to go straight into the simulations. Coach and I have already got y'all on a list. We're going to email Mr. Hallowell, and then they're going to order and get basically everybody a copy of the simulation that I'm going to be showing you this evening. And that way we can practice with that. I'm also working on getting everyone in this Saturday to do lab work, just because everything's been changing as far as the policies go, and I'm trying to get it where we can get some time in there and get y'all with some hands-on. So I'll let you know more about that when we come back and everything. But yeah, we'll do some simulations. It's much easier than just reading about them on slides. And I'll see you guys at 8 o'clock.